Hello and good afternoon, and welcome to this video tutorial where we're going to be talking about OSPF sham-links, and we're actually going to be using the reference architecture that you see up here to the left, which is actually comprised of all physical Cisco 1841 routers. As you can see, I have the iOS version here. So on the left hand side we're running 12.4.24T2, and on the right hand side we're running 15.3 3xb12, which is a developmental train of code. Okay, so really a quick review of what the sham-link is for is basically when we have an MPLS setup like this and we introduce what is referred to as a backdoor link, right? And this is our OSPF backdoor link here, and this is the subnet that link sits on. And for our purposes, I've basically directly connected two interfaces, FA01 on both of the customer edge routers. And this could be anything. I mean, it could be a T1 link, it could be a T3 link. So any link that you have as sort of a backdoor link, just in case for whatever reason the MPLS provider cloud goes down. And so let's go ahead and take a look right now on customer edge router 1, and let's see what his view of the network looks like. So if I type in show IP route, you can see that he is learning the loopback address for the customer edge router 2, and here's the loopback right here, and you can see that the route is coming across the MPLS layer 3 VPN and what is referred to as the super backbone, and we're learning it as an inter-area, right? So it's a type 3 LSA that's coming across. And again, the reason for the type 3 LSA coming across is because via multi-protocol IBGP, there is no way, and again, this is via multi-protocol IBGP, there's no way to bring the type 1 router LSA and the type 2 network LSAs across. And again, you'll notice I'm stressing natively via multi-protocol IBGP. So this kind of becomes a problem for us when we introduce a backdoor link, because as you can see right here, we have inner area routes. So if I were to ping, let's test connectivity, and let me clear the screen here real quick. So if I were to test connectivity over to 10.2.2.2, you can see we've got connectivity. If I was to trace my route over there to 10.2.2.2, you'll see that what's going to happen is the traffic, and the backdoor link is down right now. Want to make sure we point that out. So the backdoor link hasn't been introduced yet. So what you're going to see here is the traffic is actually going to go out to the provider edge 1 router, which is the 11.2 interface. It's then going to traverse the MPLS layer 3 VPN super backbone, right? And you can see where it picks up its MPLS label, and then it's going to reach the other side of our MPLS cloud and reach its destination. So as you can see, we have end-to-end connectivity right now. Let's take a look at what the customer edge router 2 sees. So if I were to say show IP route, we're going to see much of the same thing here. You can see that he's learning about the transit network 192.168.11.0 via a type 3 LSA, and he's also learning about the loopback of router, or the customer edge 1 router, and that is also coming across as a type 3 LSA. And so this raises the question, what happens when you bring up the backdoor link? And so let's do that. And oftentimes a backdoor link is used just in case of an emergency, where if for whatever reason you lose your MPLS layer 3 VPN connectivity with the provider, you still have some way to stay up and operational. But here's where the challenge comes in. So if I were to go ahead and go into global config mode here, and we're going to say interface FA01, and I'm going to say no shut. So now we're going to bring up the backdoor link, the interface over on CE2 is already up. And so what's going to happen is the backdoor link is going to be, and there we go, as you can see the interface just came up, right? And so now what will happen is OSPF is going to converge. So what's going to happen here on this backdoor link is these are going to be seen as intra area routes, right? Because we have a direct connection here. So these are going to be seen as intra-area routes. And unfortunately, when the routes go across the MPLS super backbone, right, and they go this way, they're seen as inter-area. Whoops. They're seen as inter-area routes. And so if you go back to basic OSPF, remember that intra-area is always preferred over inter-area, and that is irrespective of the cost. So I could set the cost on the intra-area to the max value, and the inter-area the intra-area will still be preferred over the inter-area, right? Because again, and it's a tough transition. I teach the CCNA curriculum for the Cisco Networking Academy, and one of the things you stress to the students is, the IP OSPF cost, and we really point out, cost is the #1 determinant when we're talking about OSPF. Well, in the CCNA setting, this is true. However, as you advance on, you'll quickly learn that intra-area is always better. No matter what the cost, is always better than inter-area OSPF routes. So these type 3 LSAs that we have up here are not going to be preferred over our type 1 and type 2 that are going to be going back and forth this way and this way. And so our OSPF process has converged here. So now let's do a do show IP route, and let's see what the customer edge sees. So as you can see, and we'll scroll back up here, prior to this we saw the 10222 as an inter-area OSPF route, because again, across that MPLS super backbone it's going to be a type 3 because the provider edge router is performing the duties of an ABR, right, as well as an ASBR. So when he receives the route, it's going to get sent across the backbone, but it's going to be redistributed out as a type 3. But now when I bring this backdoor link up, as you can see here, we are now intra-area routes, not inter-area routes. These are intra-area routes with just the O, and they are automatically preferred over the inter-area routes. And so let's go ahead and let's take a look at what the cost was earlier. So the cost was 11 for my inter-area OSPF routes coming across the MPLS Layer 3 VPN super backbone. So let me go ahead and change the cost. So let's say IP OSPF cost, and what value can I put in there? The max is 65,535. So let's do 65,535, right? And I'm going to go over to the other side here onto customer edge 2. We're going to say global config and interface FA01 IP OSPF cost 65,535. Whoops, 35 there. All right, so I have literally set the OSPF cost to the maximum value to prove that even if I do the do show IP route, as you can see, the cost is the 65,535 plus the cost of 1, which was the cost, I'm sorry, 65,536, which was the cost prior to making it 65,535. So again, we've changed the cost to 65,535, and now it's bumped up to 65,536. So if I were to do show IP OSPF interface FA01, you can see that the cost is $65,535 out that interface to get over to CE2. And then if I come over to CE2, I would say do show IP OSPF interface loopback 0, which is our 10.222 loopback, and the cost is simply 1, right? So that's why when I do a do show IP route, and I want to make sure I'm clear on this, I was kind of fumbling there prior. So 65,535 is what we set it to, but the cost is 65,536 because we have to take into account the cost of the loopback interface. And so that's why it's 65,535 plus 1, right? And prior to this it was 2 because it was costing us 1 for the link and then 1 to get to the loopback. So again, that's how you would determine the cost. But as you can see, what's happening here is the intra-area routes are still preferred over the inter-area routes. So now let me take off the cost setting here because we're going to tweak this in a second, and I'm going to let it go back to its default value, which was 2. So do show IP route, and we'll give it a second here to adjust. All right, there we go. And so again, if I did the do show IP OSPF interface on FA01, you'll see that our cost is 1, and then we know the loopback on the other side, the cost is also 1 for a grand total of 2. Okay, so now this brings up a good point, right? Because if for whatever reason your provider connection were to go down, you would want to make sure that your backdoor link, irrespective of whether it's a T1 or a T3, that's your secondary link. Because chances are it's going to be slower than the link you have to your provider. And again, if it wasn't, and that's what you wanted to use for your primary link, then you could use what we're doing right now, which is simply just bringing the backdoor link online. And if that backdoor link goes down, so we're going to say shut on FA00, and again, this is sort of the alternate scenario is where you want to use the backdoor link, but for whatever reason, your use case is that your MPLS Layer 3 VPN through the service provider core is your backup. So if I were to shut down the backdoor link, you can see what's happening here. The OSPF adjacency has gone fully down. If I do a do show IP route, we should still see, oh, it changed pretty quick. So it actually changed rather fast, and we right away have failed over to our service provider path, which is across that MPLS Layer 3 VPN. So again, if this is your primary setup where you want to go across the MPLS Layer 3 VPN, the provider core, then when you bring the backdoor link up, because you want it to be automatic as well, you don't want to have to call a network engineer and say, hey, our link to the provider is down. What we need you to do is to get on to the customer edge router and bring up that backdoor interface. Now that could be your game plan, but chances are you would prefer, and you can see here, so we still see the inter-area routes, right? It still has the entries for the inter-area routes, even though we've brought the backdoor link up, but this will change here in a second, and I believe we're going to get a message on this side telling us that the adjacency has gone from down to full, or from loading to full, sorry, from loading to full. And now when we take a look, we still have it, but it's going to clear out of here in just a second. And giving OSPF some time to figure itself out here. And there we go. All right. So where are we at right now? So we've got the backdoor link is up. And let me go ahead and clear this layer out here. Whoops. I'm going to clear that layer out. All right. So the backdoor link is up, right? But our problem is all our traffic now is coming across this backdoor link. So if for whatever reason, let's say this was a T1, right, 1.544 megabits per second. And maybe our connection out here is 100 megabits per second. What we don't want is the traffic to be coming across this backdoor link. And so that really leads us to what this whole video tutorial is about. It's about the sham link, is to how do we make it so that the backdoor link is less attractive. And I guess the flip side of that is, how do we make it so that the service provider core is more attractive? Well, again, if the service provider core is going to be redistributing the type 3 LSAs from one edge to the other edge, we've got to come up with some way to allow it to transfer type 1 or to transmit type 1 and type 2 LSAs. And it wouldn't be a virtual link that we're going to use. It's going to be what's referred to as a sham link. And a sham link is basically a point-to-point intra-area link, right, that allows us to let the type 1 and type 2s transit via this link. And again, it's not being, you're not sending it across via multi-protocol IBGP, right? You're actually having to put this link in place. And so the link is going to originate from one PE router over to the other PE router. And so this is going to be our sham link interface here. We're going to use 2 loopbacks, one on each side, right? We're going to make them /32s, and we're going to make sure that we redistribute them into BGP via BGP and not OSPF. If we did it via OSPF, what's going to end up happening is that sham link is going to end up flapping continually, and that is definitely not what we want. So let's go ahead and start. The first thing we need to do is we need to create on the provider edge routers the loopback interfaces that are going to be used for the tunnel endpoints, basically, for the sham link. So we're going to go into global config mode. I'm going to say interface loopback, and it's going to be just simply we'll use loopback 10 on this side, and we'll use loopback 10 on the other side as well. Or actually, what do I have up there? I have 12. So let's say no interface loopback 10, and let's keep with the diagram. So we'll say interface loopback 12. And what we want to do is we want to put this interface into the VRF, into the customer VRF. So let's get beyond that there. So VRF forwarding, and we're going to say customer A, right? Now we're going to put our IP address on here. So IP address 192.168. Oh, sorry about that. So 10.12.12.12, and our mask is going to be /32, and you could throw a description on here that just says sham link for CE1, right? So that's the first step, is to create the sham link. Now the second step is to go ahead and make the sham very similar to the virtual link, where you make the entry under the OSPF configuration. We're going to do the same thing here. So let's do a do show run section OSPF, and there's our OSPF, and we're looking at router OSPF 99, process ID 99, VRF customer A. So I say router OSPF 99, VRF customer A, because it's within the customer's VRF that we're going to create this sham link, because this is what's going to extend across the provider cloud, right? The sham link tunnel, if you will, or point-to-point demand circuit, sometimes you hear, or demand link, right? This is what's going to create that for us within the customer VRF that's going to allow the transfer of the type 1 and the type 2 information to get across that cloud. All right. So now we're at the sham link. So we're going to say area 0, because that happens to be the area that the CE to PE relationship was created in. So area 0, sham link. We do the source address, which is going to be 10.12.12.12. We do the destination address, which would be 10.21.21.21. And now something very important, right, is the cost. And we're going to manipulate the cost again on the backdoor link. But for right now, we're going to go ahead and set the cost to 25 for our sham link. And I apologize, I need to get cost in there. So we're going to set that to 25 on our sham link. And so now it's really a three-step process. Create the loopback interface that we're going to use and make sure that it's in the right VRF. Come into the VRF instance of OSPF for the customer in question. Create the sham link, which was step 2. And so now we're simply going to go in and we're going to advertise this via IBGP, right? Because we need to make sure that this is going to get picked up in a VPN v4 route. So we're going to go over to router BGP 100. And before I do that, if I do show run section BGP, this is what the BGP config looks like, right? And you can see here at the bottom we have our address family, IPv4 VRF for customer A. So let's go ahead and jump in there. IPv4 VRF customer A. And what we want to do is we just simply want to advertise it with the network statement. So 10.12.12.12 with a mask of 255, 255, 255, so /32 mask. And there you have it. And so that is really the sham-link configuration on the provider edge side. And you're probably asking yourself, well, wait a second, what if my provider won't do this? Well, then you might run into some issues, because as you can see, nothing is really getting done on the customer edge routers. All of the heavy lifting for the sham link is going to take place on your PEs, on the provider edge routers. So some providers may come back and simply tell you, yeah, no, we're not doing that. We're not going to set that up. So let's come on to the provider edge 2 router, and again, same process, right? So we're going to say interface loopback. Let me make sure I get this right. So we're going to say interface loopback, or actually, yeah, interface loopback 21, and we're going to say VRF forwarding customer A, and the loopback interface is up. So I'm going to add my IP address on here. So this was going to be 10.21, right, from 2 to 1 instead of from 1 to 2, and then /32. So do show run interface loopback 21. You can see that we've got our loopback interface that's in VRF forwarding customer A, so in the VRF for customer A, and our IP address is 10.21.21.21. All right, so again, that was step 1. Step 2 is simply going to be to do a do show run section OSPF. And again, it's router OSPF 11 on this side. So we would say router OSPF 11 and VRF customer A, right? So we go into VRF customer A on this side where we create the sham link. So area 0, sham link, and then the source is going to be 10.21.21.21, the destination 10.12.12.12 with a cost of 25. And so I'll hit enter. So has this changed anything yet? Again, we haven't redistributed via IBGP yet, but on the customer edge router, if I do a show IP route, right, I've actually picked up the external type 5 that's coming via, we pick it up via OSPF. And as you can see here, the 10.12.12.12, which is over on the provider edge router, has been picked up because we have redistributed that into BGP. What does customer edge 1 see? Do show IP route. So as you can see, he's picking up the 12.12.12 as well, but there's no entry here for the 21, right? So again, we have no entry here for the the 10.21.21.21 from over on provider edge 2 because we haven't done the redistribution yet via IBGP. So let's knock that out right now. So do show run section BGP, and so here's my BGP section, and as you can see, we've got IPv4 VRF customer A. So let's jump in there, router BGP 100, and we're going to say address family IPv4, and is going to be VRF customer A, right? And so from here, all we're going to do is advertise that network via IBGP. And it's going to be a network statement for 10.21.21.21 with a mask of all 255s. And so as soon as I hit enter here, I'm going to jump over to here and let's see, have we picked it up yet? 10.21, and yeah, actually we did right there on the first go. So it actually picked it up rather quickly, right? So as you can see, we're picking up it as an external type 2, right, an E2 route, and here it is. Now, why are we not picking up, or why are we not selecting the routes or installing the routes into the routing table for the sham-link, right? Because the sham-link is giving us the type 1 and the type 2. However, we're still selecting the, if you look right here to get to 10.222, we're still choosing that backdoor link. So let's check to make sure, right? Is it still picking that backdoor link? It is. If I do trace to 10.222, whoops, extra 2 there. Let's see where the trace goes, but we already know that the backdoor link is up. The cost of the backdoor link is 2. And we set the cost of the OSPF sham link, that cost got set to 25. So what we're going to do now is let's go ahead and make sure, let's take a look and see if I were to do, you can see the sham link went from, is up. So if I were to do a do show IP OSPF sham link, or actually sham links, right? So here is our sham link, right? It's in area 0. There's our source address, and we're on PE1 right now. So there you have it. Run as demand circuit, right? The cost is 25. So you can see right there our cost is 25. And this is why we're not allowed, or this is why we're not installing this into our routing table on either side, because the cost is greater than it is for the backdoor link. So what are we going to do? We set the cost to 25 on the sham link. So let me go ahead and put that in there. So the cost that we set here was 25. And so this is where with OSPF cost, and we're dealing with two scenarios here that are both now intra-area, right? So now that these are both intra-area, now cost is going to come into play. Whereas before, one was in, or I should say up here, one was inter-area prior to the sham link, and this was intra-area. And again, really the only use of the sham link is to solve this problem. So let's do this. We're going to set our cost down here. It's going to be set to 50, right? So let's jump on the backdoor link. And I believe we're in there. Let's make sure FA01. And we're going to say IP OSPF cost 50. And we want to go to the other side. You want to make sure you do it on both ends of the adjacency. IP OSPF cost 50, or else you would end up with, you could end up with black hole routing, or, you know, results that are unexpected because you've got different costs on either side. Whoops, FA01, IP OSPF cost 50. All right, so if I do a do show IP route now, what do we have? So as you can see, we're still, oops, sorry about that, did not mean to shrink that. We're still picking up both type 5 routes that are coming from the provider edge routers, and we're still using, so if I'm on, this is customer edge 2, right? I'm still looking at that backdoor link. But let's give OSPF a second, and then let's run it again. And there you have it. So now, how are we going? Cost of 28, right? Whereas before the cost was 2. We increased the cost of 50 on the backdoor link. And so now what's the preferred path? The preferred path is over the provider cloud. Let's make sure that customer router or customer edge router 1 is in agreement. Do show IP route. And as you can see, customer 1 to get to 10,222, he now agrees that with a cost of 28, it's more advantageous for me to transit the provider core to get over to customer edge 2 than it is to come across this backdoor link, right? So now this begs the question, is OSPF going to, in the case of a failure on the provider side, and this is really, this is really the use case that's not only the most popular, but is probably the one that you're going to run into is, okay, so I've got my backdoor link. That's obviously not the preferred link. So I'm going to get the provider route installed into my routing table. So what happens if the provider link goes down? Does the backdoor link come online immediately? Well, let's check that out. And first, let's do a quick trace over to 10.2.2.2 to see that I'm actually using the provider route. And so I'm basically going to shut down interface FA00 on customer edge 1, which would signal that the provider link, for whatever reason, has gone down. And so there you see my first hop is over to the PE1 interface, and then I go across the MPLS cloud, and then I should land at the CE2 router, and there it is. I hit the CE2 router, and then I hit the Loopback interface. And do I have full connectivity? Do ping 10.222 to make sure that there are no anomalies, right? So we're good to go there. All right, so now let's simulate a failure. Let's say that for whatever reason, the customer edge 1 router lost its connectivity to the service provider MPLS layer 3 VPN transit point. So we'll go to interface FA00, and what we're going to say here is just simply shut. So do show IP route. So as you can see, we've lost a lot of our information, and then look at that. Almost instantaneously, OSPF quickly came back up and brought into the routing table the backdoor link with a cost of 51. Because remember, we set the cost to 50, and then the hop to get to the loopback is going to be 1, so 51. So we lose our link to our service provider core, and because we have this backdoor link, let's check it out. So let's say do trace 10.2.2.2, and let's confirm that we can get from CE1 to CE2 via the backdoor link. And it's going to take a second here. We'll give it a second. So there you go. One hop, right? Right over to CE2's IP address, and then right to the loopback address. And do we have connectivity? Do ping 10.2.2.2. Perfect. So again, this is probably the use case that you're going to run into where you want to take advantage of that expensive service provider layer 3 VPN service and using their backbone. But if for whatever reason your link to the provider goes down, you want to make sure that you can still get to the customer edge 2 router to get to that site for whatever the reason may be. And setting up the costs in OSPF will allow you to easily do that, so that when there is a failure to the provider, your backdoor link comes online immediately and you're still up and operational. So I hope that that this has kind of cleared up the use of the sham link, as well as why you would want to use the sham link and in which scenarios. And we've actually gone over a couple failure scenarios as well. And so again, hopefully you're going to find this this video of value to you in your studies or in your real world. And that's it. All right, so thanks for watching, and I'll see you soon.